Welcome back to Data Solution. I hope you're doing very well. In this video, we are going to take hand-on approach to build an end-to-end data solution project in Microsoft Fabric. And for that, we are leveraging the Medallion architecture. This Medallion architecture, one of the most widely used data lakehouse solution implementation. It's give us the structured way to maintain data quality and also ensure the optimized performance at every stage of the pipeline. So here the flow we will implementing, we will start with data ingestion from raw layer to landing layer, and then we will move it through the landing to bronze in which raw file is inserted, and then move it to silver in which we do some data cleaning and business transformation. Then from silver to move it to gold layer in which we will segregate one big table into dimension table and fact table as a transaction table, and then finally we will make it available for reporting in Power BI. Each stage, we will orchestrate the process with pipeline, ensure the transformation and manage parameter so that entire solution is not just working but also automated and scalable. By the end of this project, you will see how data travel from raw files all the way to insightful dashboard powered by Microsoft Fabric and Medallion architecture. So let's begin by looking at the end-to-end project architecture so that we will going to build. So before going to forward, I request to viewer to please subscribe the channel and like this video if you find this video helpful to you. Now let's get started. All right, let us now set up the required workspace and fabric item that we'll be using to continue this project. I am currently Fabric homepage. Now let's go ahead and create new workspace. Click on here, workspace, and you can see existing workspace, but I don't want to use these, and let's create brand new workspace. Click on here, new workspace, and name it Fabric Dev. Fabric Dev. This will act as our development environment where we will build all the required item for this project. Now, don't forget to expand this advanced option and ensure that you can choose here trial option if you're using trial version. Once the choose trial version, click on apply button. This will create new workspace. Okay, now next let's also take a look at dataset that we will working with. I will open here folder where our file are stored. You can see here multiple file which we generated regularly in monthly or daily basis. For example, for 2015 April, let's open one of the file, and you can see here the file detail. This basically file contains sales data in which we have row ID, order date ID, order date, ship mode, and here customer detail. For example, customer ID, customer name, segment, postal code, city, and state. Like also you can see here country and region and market. And you can also see here product detail. For example, product ID, category, subcategory, product name, and sales information, sales quantity, discount, profit, and shipping cost, and other you can see here detail. Okay, so basically every row here represent single order placed by customer, covering everything from purchase to delivery. Now this dataset allows us to analyze some really important business scenario like sales and profit over time, region and market performance, subcategory and subcategory, impact of discount on profitability. These insights are exactly what business rely on to make better decision. This is simulate real-world dataset, which make it perfect for our practicing end-to-end project for data analytics using Fabric. And just like in real-world business scenario, we will expect this file to be generated regularly. So we will take here multiple file for monthly or even daily basis generated. Okay, so let's assume here monthly basis containing transaction for that. Okay, so that's all about data set. Now next, let us now discussing about taking the sales data from raw layer to landing layer. In real project, the incoming data is stored incrementally in landing zone, usually in real time. The data could come from the website or an e-commerce platform through an API. That API could push the data directly into landing zone. But since this is the dummy project, we want to simulate that scenario. To do this, we will first store the data in raw folder inside our Fabric Lakehouse folder. Here we will manually upload the sales data file into raw folder. Each file will be represent the sales transaction for that particular month. This could contain all sales transaction for that month. The expectation is that only one file will be uploaded per month containing all order for that day. Next, we will going to create the pipeline that pick up the latest file from raw folder based on last modified date. This file will then copy into landing folder and partition by processing date. And here processing date simply means the date when the data is moved into landing zone. For example, if today is 23rd August 2025, then one file will be created of the name of today date inside this folder and will store the sales transaction for that month. We will also add the processing date column into data so that we can always track when the data was ingested. So let us quickly walk through the step. First, data arrive in raw folder in CSV format. A pipeline will incrementally copy the latest file from raw to landing. Data will partition by processing date in landing zone. Each month, a new folder will be created in landing with that day processing date. Okay. If today is copied, then one file will be created in landing zone. Okay. Now let us create the lakehouse in Fabric. Let us go back to homepage of Fabric and go to here Workspace and just we created here Fabric dev. So click on this and open this Fabric Workspace and click on new item and go to here store data section and click on lakehouse. To create lakehouse, give a name of lakehouse, Fabric lakehouse sales, and also check mark here and create. This will create lakehouse inside our Fabric. Let us also create here folder. Click on new subfolder and name it row and click here create. Also create one more folder here landing and click here create. We will upload manually in this file. So let us upload also one more of the file. Upload file. Go to here and practice data set. Let us upload February file and upload. Then we will incrementally process the data into landing zone. All of these will be automated using notebook. We will later call from this notebook using pipeline. And going forward, we will move data from landing zone into bronze layer, silver layer, and gold layer in proper incremental data pipeline. This way, we don't copy the full data set again and again. Instead, we will only load the new data incrementally, which will the best practice in real-time analytics pipeline. So this is how we will handling data from row to landing in our sales data project. The next, we will start implementing this step by step. Now we are going to take our data from row layer to landing layer, and we do not want to move everything from row to landing layer every time. Instead, we load data incrementally. To do that, we are going to create here Fabric notebook inside our project. To create Fabric notebook, go to here, open notebook here and create new notebook and let me rename here row to landing notebook. Okay, now let me create here cell and expand this, expand here file name. You can also create notebook from workspace itself, so I have already created. And let me copy this abfs path and create variable adfs path and paste here inside single quote. And we have this path. This is actually container name, account name, and this is actually container name dfs fabric.microsoft.com, and this is the our qualify address of path. Okay, so this is a variable. Let me execute and let me also create two more variable, which is file name. Every time this file name change, so I'm creating variable. For now, I'm using 2015 dash fab.csv because inside this row folder we have this file name. So let me use this file name 2015 space fab, and we need to also create one more variable later this cell going to be as a parameter, and this parameter used in pipeline. So for now, I am creating here variable only, and today is, for example, 2025, 24th August date. So let me execute and let me create full path of this file address. So let me create one more variable, full path, and let me use fstring function, and inside let me use curly bracket, and first we need to write here abfs path, and after that forward slash, again use here curly bracket, and let me use here this file name and enclose with single bracket, and now let me print this full path and execute. And you can see here, if you copy this file path, you can see here same. Okay, so this is our qualified abfs path. Okay, now let me read this file and create data frame. Use here df as a variable of data frame, and write here spark dot read dot, which is csv format. So let's use csv, and inside we have a need to write here path, which is full path, and we have a header in this file, so we need to write also here header equal to true, and we need to also infer schema. So also this is going to be true, and let me create, and let me also use here display command to display this data frame. So we successfully read here. Let me collapse this, and we successfully read here this file. Okay, from row, and this we have a file name 2015 fab. This is file name. Okay, now let me add in this data frame process date. Okay, so in order to add this process date, we need to import here one of the function, literal function. So let me import from Pyspark dot SQL dot function, and import here lit function. Okay, and after importing, we need to create here new data frame. Let me create, and from df we need to add column using with column function, and in this with column function, first we need to write here column name. So column name going to be processing date, and need to use here literal function, and inside lit function let me use this variable which we created here, process date. So let me use here, and let me also use here display, and inside display use here new data frame, new, and execute this. So let me wait here. This is executing this cell. Now you can see here this processing date column is added now, and in here you can see only date year column, and now in this data frame we added here successfully processing date column. Okay, so and now let me write again here some condition. If this is not null, then we are not going to write, so or print. So we need to write here if condition, if df dot count or greater than 1, then we need to create here this function, this column. Okay, so and also comment display function for now, and write this df dot new function to landing zone to write here. Okay, if this data frame contain data, then we need to write in landing. So we use here if function, and write here df underscore new, we need to write which is in format CSV. So right here CSV. After that, we need to write option which is in dictionary format, key here header which is going to be true. So right here header which is true. Mode is append. We do not want to overwrite, so use here append. You can use here append, overwrite, or ignore. Okay, so we are going to we here append. So right here append, and we need to also do here partition. So in order to do partition, we use here partition by, and what column we need to partition by? Here processing date, and save this in landing. So let me copy this ABFS path and paste here. Okay, and let me print here some data loaded to landing zone successfully. Okay, and if this if function is false, then we need to write here else print here just file contain no data. Okay, you can also write here print for now this file has data. Okay, so let me execute now and just see. So we successfully executed this cell, and let me verify. Click here, and you can see here we successfully loaded this file into. Click here, and this is our partition by processing date, and inside we have a file. Okay, so we successfully write from row to landing zone using notebook. Okay, so now finally we write this data into landing folder and partition by processing date. So data is written in append mode, meaning we kept everything as is without overwriting. Okay, and there it is a folder today processing date with ingested file inside. Okay, to summarize, we uploaded the file to row layer, created a fabric notebook to ingest it incrementally, and added a process date for partitioning and store it into landing zone. Let us now see how exactly we can perform the incremental loading by taking the notebook just we have created. So here we actually taking two things as a variable, file name and processing date. These two values will change depending on the available data. That means this process will completely data driven. Now, since these two values are currently hard coded, let us first understand how incremental loading work using this. In next month, this file changed from Feb to March, and processing date also changed from August to September. Means 8 becomes 9 and February becomes March. So let us suppose go to here lake house and go to here row, and let us upload next month file. Okay, so let me upload file, go to here, and let's use this says data practice folder. I will upload this practice file also in description box, and currently using here have data. Now let us use mass data, and let us suppose, so let me first upload, and let me suppose date modified date here is becomes 8 to 9. Okay, means August to September in next month. Okay, now let's go to here notebook, and let me change. Let's also move to below this cell one down, and this variable at top level, and also delete this one. Okay, so now let's change Feb to March, and also change this 8 becomes 9, and let me execute all cell. So run this, and executing here this cell. So let me wait to execute. Now you can see here the data has been copied successfully into landing zone. So let me verify, go to here again lake house, and let me refresh this. And now you can see here, let me expand this landing zone, and you can see here processing date 2025 0924. means we successfully loaded. Let me open this and let me also check here. You can see here header and all data for March month. Okay. So let me go to again here notebook, and only thing we need to do here, parameterize these two variables. To how to parameterize? Go to here this cell, click on this cell and click here three dot and click here toggle parameter. Okay. Now again toggle parameter. Now you can see here parameter. Okay. Now this cell becomes a parameter. So now these two value can be passed directly from the data pipeline which we used later in this video, and uh, on the so the notebook will automatically pick up the latest file name and processing date from the pipeline we passed by pipeline, and that's what make the pipeline automatic and data driven. So in next step, let us create pipeline to automate this notebook. Okay, let us now create a data pipeline so that we can make our sales data processing automated and data driven. So before building the pipeline, we want to make sure everything is clean. So I will delete all previously created content inside the landing folder, as well as also remove the file from raw folder. So this way we will start fresh and the pipeline handle everything for us. So let's go to here fabric workspace, go to here lakehouse, and first delete from the row. So let me delete. We want to start from the fresh. So let me also delete and go to here landing folder as well. Delete this one. So I have deleted all file from row and landing. So we start from the fresh. So now let's go to here workspace and let me go to here new item, and you can see here data pipeline. So let me click here to create new data pipeline and name it PL row to landing, and name it this one in capital letter. Okay, and let me click here to create this pipeline. All right, this pipeline has been created. Now go to here activity tab and let me add here get metadata activity. So this will check the raw folder and fetch detail about available file in raw folder. So by the end of the day, you remember the one file will place monthly basis. So we should see exactly one file uploaded. So let me configure here first get metadata from from raw, and we activity state should be activated. Now go to your setting and let me use fabric LH sales, which is we created lakehouse for this project, and let me configure here root folder. We need to fetch here files. So let me use here browse, and we want to configure here root folder. So let me use here root folder, and file format should be delimited because our file is in CSV format. And field list, and in field list what should we going to we do here, we need to select here child item, select the file name from the row folder. Okay, and if we go to here advanced, let me expand this. I will set here start time and end time, so that start of the day using start time. So let me use here add dynamic content and go to here function, go to here this one date function, and let me use here start from the day function. Yeah, this one start from the day, and let me use here UTC function. You can also see here UTC. Now this will return the start of the day time. Okay, so let me click here. Okay, and let me configure here end time. So also add here add dynamic, and this will also we use here current date time. So let's use UTC now. Okay, let me click OK, and let me go to here, and let's also go to here row folder in lakehouse, and let me add one file. Go to here and let me add fab month file and upload. This file has been uploaded in row folder. and let me execute, and we want to get that file name from using get metadata activity. So let me run this, save and run. This will return file name from the row folder. Okay. If you check output, let me run this first. You can see here pipeline status in progress, and here is activity status succeeded. If you check here output, then you can see here the file name 2015 fab, which we placed here. Okay, so we successfully get the file name. Now let me add, go to here for each activity. This will loop through for each activity to loop through the file, but since our business rule is one file per month, it will only return one file. Okay, so let me drag this in canvas, and let me link with on success link to for each activity. And now let me configure this for each activity, name it, and go to here setting. This should be activated, and go to here setting. I want this for each activity in sequence, and item should be here. Go to here add dynamic and get data from row child item, means this return the file name. Okay, and let me click OK and go to here activity tab. You can also click here, or you can also use here this pencil icon. Okay, so let me click here, and inside this I want to use here notebook. So let me go to here activity tab, or you can also see here notebook, and you can also see here search here notebook. Okay, so let me drag here notebook, and let me configure this notebook, rename this row to landing notebook. Okay, activity status should be activated, and go to here setting and workspace. We use here fabric dev notebook. We use here row to landing notebook, and base parameter. I have a parameter in this notebook which is file name and process date, which we converted previously this cell into parameter. So let me copy first file name and go to here pipeline, and let me add parameter, name it, and paste its file name. This should be a string, and file name value should be coming from the for each activity. So let me add dynamic and for each activity content, which is item dot name. Okay, so let me click OK, and let me add one more parameter. Go to here and let me copy this second parameter and go to here pipeline and paste here, and this should be also a string data type, and this value should be, so go to here function, go to here date function, and let me use here format date time function, and inside this format date time I want to use here UTC. Now this return current date time in format of, I want to use here format YYYY 4 times dash dash TT. Okay, let me click OK. So this will return today date in YYMM and DD format. Okay, so in advance we do not want to do anything, and let me go to your home page, save this pipeline, and after saving let me execute this pipeline. Okay, so if we click anywhere in this canvas, you can see the status of this pipeline running status. Okay, pipeline is executing. You can see here in progress, get metadata activity is succeeded. Now you can see here our pipeline is succeeded, and also notebook activity is also succeeded. So let me check here notebook. You can see here succeeded. Okay, if you want to check notebook, click here row to landing notebook, and you can see here the notebook snapshot. So let me click here this link. So if you let me load this and collapse this, and you can see a notebook, we got here parameter. This is written by pipeline, and this is file name and today date, and this should be executed. Okay, so this file has a data, and data loading to landing zone successfully. Okay, and let me go to here workspace. I'm using here fabric dev workspace. Let me go to here our lake house and go to here landing, and you can see here process date file written successfully, which we clean previously. Okay, in this way we create here pipeline to execute notebook. Now let's see how to ingest our sales data from landing to browse table. Here we created initial table so that we can insert, update and delete as well. We have full control on table. Now let's see how to ingest our sales data from landing to browse table. To load data from landing to browse, let me create new notebook. You can also create here notebook. Go to here, open notebook and create new notebook. And I will rename this notebook to landing to browse table. And here automatically attach this lakehouse to this notebook. Okay, so let me delete this one and you can see here row and landing. So let me copy this file, landing file. So copy this and copy AVFS path and let me create here new variable AVFS path and paste here. We need also here one more variable which is processing date. So let me create here processing date title should be today date. Okay, so today date I will hard coded this value. Here you can see 2025 0825. Okay, so let me use this value here hard coded currently, but later this will come directly from the pipeline. Okay, so let me also create here one more variable which is partition by partition path. Okay, so let me use here fstring and this should be forward slash and here processing underscore date and equal to, and let me use here curly bracket and use here today date. Okay, and complete path should be ABFS path plus partition path. Okay, and let me print this complete path. So I want to read here basically partition file, okay, which is CSV file. Okay, so let me collapse this. And if you go to here and if you copy this and you can see here same path, okay, which is ABFS path, which we created using variable. Okay, now let me use this variable to read this file. So ABFS path here Spark, here I am creating data frame df, then read dot format which is CSV. Let me use here option should be header which is going to be true. Okay, let me use here schema. Instead of inferring schema, I want to define here explicit schema, which is best practice. Infer schema is not best practice. So let me create here. Let me use here. I already defined here explicit schema. So let me paste here. So I imported here data type, integer data type, double data type, which is string type, integer type, double type, and stack type, stacked field. And we also import here date type. Okay, so let me collapse. I am imported from Pyspark dot SQL dot type, and we defined here schema stack type, which is defined here structure field, and here is the our structure field row ID, which is string, order ID, which is string as well. And you can see here order date, which is date data type, ship date, which is date data type, and you can see here numeric value sales, which is double, quantity, which is integer, and we here explicitly defined here schema using stack type and structure field. Okay, so let me use here this variable and load our complete path. Here is our complete path. So let me use here complete path and let me execute now. So we need to run first this cell. So execute and now run this. Now let me use here display command to verify this data frame. So we successfully read data from our landing, which is partition by processing date. Okay, and we create here variable. We defined here a schema type for this processing date file, and we successfully created here our data frame. So you can see here we successfully read this data, sales data in our memory. And now let me create here our temporary view for this data frame. To create temp view, and let me use here, this is new data. So let me execute, enclose with single quote, e new data, run this. And if you execute here, use here magic command SQL, and if you use here select star from this table, we can read successfully all column and all row. So let me execute. So you can see here we successfully created here temp table, which is t underscore new underscore data. Okay. So now temporary table is created for incoming data from landing. Now let me create a browse table to store this incoming data permanently in browse table. So let me create here. I have already created a structure of table. So let me copy and paste here. So I have created here variable v underscore create underscore table and defined here as a create table if not exist, as a we name it tbl sales browse, and these are the row and these are the data type of column. Okay, so here processing date, which is going to be date, we also add here extra column. Okay, and here row id string, we create the same structure as we have incoming data, except only we add here extra column processing date. Okay, so let me execute. So this sales is executed successfully. Now let me use here a Spark command to create table, a Spark dot SQL, and let's use this variable, and let me remove here a space. Okay, so now here is table created successfully. Let me check here. This table is going to be created here. Okay, so you can see here we successfully created tbl says underscore browse table using a Spark command. Okay, so let me, if you check here, if you go to here Lakehouse and refresh this, and here is table, and if you go to here properties, and you can see here this table is going to be delta format. It means in this table we can insert, update, and delete. We can do operation. Okay, so insert, update, delete we can do here in this table. So now let me go to again here notebook, and let me use here abfs path and create here a variable above this variable. So let me use here fabric tvl sales underscore bronze and paste here this path. Okay, and then let me create temporary table if this table is not exist. So let me also use here try. If this table is not exist, then we use here try, means if this table is not exist, let me create. Okay, so let me some do intent here. Okay, and if this table is not exist, let me use here, let me create here temporary table. Okay, if this table is exist, then spark dot read dot format is going to be delta. If this table is exist, then it's create here temporary table, and here load using this path, and let me create here temp table, and temp table is going to be, let me use same table name, and we need to write here only t underscore this temp table. Okay, and after that we use here accept, and let me now use here intent. We already use here And if this table is not available in this lakehouse, then we use here except command to create permanent table. And after that, let me use again this command to create temp table. This is only true because if we use this notebook in pipeline, if this table is not available in lakehouse, then it is going to be create to make this dynamic. So we use here try and catch approach. Okay. So now let me create new cells. And if we execute this one, it is now going to be successfully. And if you use, let me use here and let me select star from to use as a SQL cell. We need to use here magic command double percentage. Then we need to write here SQL. So we can write here as a SQL script. Okay. So we here till now we created here bronze table, permanent bronze table, which is going to be for now empty. Now we need to load this incoming data into this bronze table. To do that, we need to write here merge statement. A merge statement going to do if a bronze table already data available, then it's update. If a new data is coming, if not data available in bronze table, then it is going to be insert. So I have used this merge statement already created here script. Let me paste here to save time. We use here merge statement in Spark as well. So we write here merge into this is going to be this table is going to be as a target table in which we insert incoming data or update if already data exists. So TVL says as a target table and using T underscore new underscore data, which is temporary table here we created, which is going to be incoming data. So we write here using this table as a source and we compare it by order ID from target to source. And if order ID from target table and from the source table is match, we compare with order ID and customer ID. If both is match, then we need to update. So we write here when match, then we need to update all column from target table using source. If not match, then we simply insert. We use here all column. Then we from the source we use here source column to insert all row into target table, and we use extra here date variable to insert into target table to compare our given data from landing. So let me execute now. Here 1675 row inserted only. This makes sense because currently this table is empty. If this row already exists, then it's going to be update. Okay. If any row match with permanent table in target table, then it is going to be empty. So we successfully inserted in target table. So let me now check. First, we need to use here SQL. So we successfully inserted data into this permanent table. TBL says bronze. Okay. So our sales data from landing has been successfully ingested into bronze table with full support of incremental insert and update. Now let's move on to landing to bronze to silver layer. By now, we have all our sales data ingested into bronze layer, which is TVL sales bronze table, exactly as same as landing folder. We exactly ingested same data into bronze table. Now it's time to start adding some data cleaning and business transformation so that our data is clean, consistent, and ready for reporting purpose. So let's start silver transformation. So let's create a new notebook. Go to here, workspace, and let me click here, new item. And you can see here notebook, or you, if you're not able to see this notebook, let me search here notebook. Okay. And click here. I will name this notebook as a silver transformation. So let me write here silver transformation demo. Okay. And let me attach in this notebook our lake house. So we are using this lake house for our lecture. So let me connect. Okay. And you can see here same row and landing folder, and we have only bronze table. Now let's start silver transformation. So let me write here silver transformation and remove this one, and heading here silver transformation, enter. Let me use M escape and write here M to start here heading markup, and let's start with variable today date. I am creating this variable because I want to only filter today date variable. Let's start with hard coded. Later it will do dynamic using pipeline. So 25th of August 2025, and let me use this time silver bronze table. So let me click here three dot and use here copy path for this table, and let me create here variable fabric bronze path, bronze table path. So let me use here variable and paste here. So you know this table is delta table. If you want to check, go to here this workspace and let me open. And you can see here, if you click here and go to here properties, you can see here format as a delta. Okay. So let me go to here silver transformation notebook, and let's create here data frame. So writing here start with df, and we need to write here spark dot read dot format, which is going to be delta, and I want to load from fabric bronze path. So let me use this variable. Before loading all data, I want to load only today data. So we need to import here call function from Pyspark. Pyspark dot SQL dot function import here call. And now let me use here another transformation, which is filter, and use here call function for processing date. Our processing date you can see here. Let me copy from here and paste here and compare with today date. Okay. So let me use here today date, and this should be going to be string so that we can compare and close with. And now execute. Let me validate using display command. So let me execute now. So our data frame is created successfully. Let's wait to preview data. Now we successfully loaded this table into data frame df. Okay, and we filtered with today 25th of August data only. Okay. Now let's do some business transformation and cleaning. So let's start with heading data cleaning. Data cleaning. Let's start with handling duplicate. Duplicate. So I want to mark up this one, and let's remove duplicate. So I want to remove duplicate. How to remove duplicate? Let's use df, then drop duplicate value. You can drop to remove any duplicate. And before I want to also write here for validation purpose, let's use here print function, and before removing duplicate, and let's use df dot count, and let me again copy and paste here after. So let me execute to remove duplicate value. Still running. So we do not have any duplicate value. Of course, that makes sense because our data do not contain any duplicate value. By using this function drop duplicate, you can remove duplicate from the our table or any duplicate value. So for our future purpose, I am using this code. Okay. So let me comment this print function. We do not need here. Now let's use for missing any null value. If any value contain null, then I want to drop that records. So let me use here handling missing value, and I want to drop. So let's use here drop row with missing critical value from our order ID and customer ID. Okay, so right here. heading, and let me use here function df dot drop. I want to create this data frame for remove duplicate, which is previous data frame, and let me use here drop na function, which if any value is null, then I want to drop for subset. Let me use here subset function for our column order ID. If this value contain null records, then I want to drop here, and let me also use here customer ID as well. So copy this one and paste here. Okay, and execute. Okay, so this command remove any records which is order ID equal to null or customer ID which is null in that value. That record should be removed. Okay, now let's use some business transformation. So I want to add here delivery date. Let me write here business transformation. You can do business transformation and data cleaning in silver layer. So transformation, let's use here some business transformation. I want to calculate here delivery date. Okay, right here, execute. Let me do here markup. Press M after escape, before escape, then M to create here markup as a value. So now let's calculate here delivery days. Okay. Okay, let us create delivery date column. So let's use here df days as a data frame, and let me use here previous data frame, which is df underscore drop, and let's use here with column function, and let's use here column name delivery days. And how to calculate delivery days? Simply let's use call function, and we need to write here ship date minus ship date. Let me use here minus order date. Okay. Let me again use here call function, and we need to write here this column in single quote and silver date as also in single quote, and cast this column. I want to also convert this data type into integer. Okay. Now let me execute. We need to also write here this integer function in single quote, and let me now use here display command df day to validate this data frame. Okay, we successfully created here delivery days column. Okay, so now let's do some more transformation. I want to calculate here profit margin. So let me use here profit margin, create here profit margin data frame. How to calculate? Let's use previous data frame, and let me use here with column, and write here column name profit margin. How to calculate? Let's use here call function, and we need to write here profit column, and let me divide this by sales. Okay, let me execute. And if you want to check, let me use here display command df dot what is our profit margin, our data frame. So let me execute, and you can see here we successfully created here profit margin column. Okay, so these are the our profit margin column. So we do some business transformation as well. Now let's write this data frame as a silver table. So how to write? So let me do here some heading, writing to silver table, and before writing, we need to create here temporary table. So let me create here temporary table. To create, write here create or replace temp table for silver. So our T is temporary silver new data. Okay, let me execute. And if you want to validate, let me use here magic command and use here select star from this one table and execute. We successfully executed and created here temporary table. Okay, so now let's create here permanent table for silver. So I have already created here a script. So let me copy this one and paste here. So I have created a structure of silver table, which is going to be create or replace create if not exist. TVL says silver, and these are the row and column, and this is the data type, row ID, order date, and string, which is data type. So we also add here delivery days and profit margin. This is different two column from bronze table. Okay, so let me execute this one to create table. And if we refresh this one, here is silver table going to be created. Okay, so still this executing. Now refresh this. Here silver table is created. Okay, so let me copy this silver table path to make this dynamic. Let me use this the fabric TVL sales silver path, and let me use here try and catch function as we do for silver transformation. Spark dot read dot format, which is delta format, and let me load this, and let me use this path variable, and let me create temporary table, create or replace temp table, and T TVL sales silver. Okay, and copy this one, and after that write here except if this table is not exist, I want to create a new table. So and okay, okay. So let me execute now. Okay, this statement is successfully executed. Okay, so if this table is already available, then we have created here this temporary table. Otherwise, in accept function, we create here, we write here this logic to create full table for silver transformation. And let me load data into this silver transformation for incoming data from bronze table after doing some data cleaning and transformation. So let me use here again merge statement, copy this one. I already copy from bronze table and add here some extra column delivery days and profit margin. Okay, so if we go to here delivery days, this is extra column and profit margin, and we also compare with order ID from source and target our TVL says silver as a target. This table name says silver, and our source table TVL says new data, which we created here T silver new data. Okay, so let me execute. If this order ID from target and this order ID from source is match as we, or also customer ID from the target and customer ID from the source is match, then I want to update all row from this table. Otherwise, I want to insert new record to silver table. Okay, so let me execute. I will also put this all silver transformation in description box, this notebook, and you can copy and download from there, and you can do practice as we do here. So of course here all record is inserted into silver transformation because there is no any record in silver transformation currently. Okay, that makes sense. So let me validate. Let's use here SQL, and let me use here select star from TVL sales underscore silver. So you can see here preview of our silver transformation. So now our data is clean, transformed, and written into silver with insert and update logic. From here, our data science or our reporting table is created. We can build a gold layer for reporting and Power BI reporting purpose. Okay, so now let's start gold transformation. Now we are going to take our sales data from silver layer to gold layer. At the silver layer, our data is ready and clean and transformed. It has a data quality we needed, but it is not yet ready for business consumption. So now it's time to bring this data into gold layer where it will be used by business user and the Power BI dashboard. In gold layer, we don't just dump one big table. We actually design our data model and splitting into fact and dimension table. So for this sales data, we will use here star schema. Let me open here diagram. And that means we will one fact table, and in which we have a transaction detail and multiple dimension table. For example, dim customer and dim product has a dimension table, which is connected with one-to-many relationship from dimension to fact table. Okay, here is the product is dimension table, which is unique, and here is more detail in fact table, which is transaction table. Okay, so we have created in this from one big table into splitting into three table: dim customer, fact table, and dim product table. These table connected using our key here, product ID, and product from fact table product ID. Here is a multiple, and here is a one to many. Here one to many from dimension to fact table. Okay, relationship using key. Okay, so now let us create. Let me go to here our workspace. Let me create here our notebook. Let me click here. Now I will rename this notebook to silver to gold transformation. Okay, so let me enter here. Let me use here as in caps letter. Okay, let me attach our lake house as well. Okay, so here is the our row, then landing, then we create here bronze layer, then silver layer, and now we are going to create here gold layer. So let me again create here variable which is today date. Here I will hard coded it for now. Later it will come from dynamically from pipeline. Okay, so let me execute. Here is session started. Okay, so let me wait and for this sales execute. First time it take time. After that, after session is started, then it does not take much time. Okay, so here is 15 second we taken for to start this session and to execute this cell. Now let me import some function from Pyspark dot SQL dot function. I'm importing here call function, and let me read this silver table as a data frame. So let me use here spark dot read dot format. Then format is going to be delta. I will already show you, and let me load using AVFS path. So go to here and click on three dot and copy path in single quote, put here, and let me also filter with today date. So let me use here and let me use call function, and I'm going to we filter using processing date. So this is the our processing date. So let me use this processing date, and I'm comparing with string function of today date, which is our variable. Okay, here is today date. We already created here variable. So let me execute now. Let me also create a new cell, and let me display this data frame. Okay. So our data frame is created, and here we successfully get 25th August of records in our DF data frame. Okay, so let me also print here DF to print schema for our column and date. So this is a method. So here we need to use open and close bracket. Okay. Okay, now we are going to split this silver table into multiple dimension table and fact table. So let me first create here dimension table. So let me heading here creating dimension table, dimension table, and let me first create dim customer. Tap and press M to heading this, and let me create a new cell, and I have already created a script to create dimension table from our data frame DF. So let me use our script to save time, take much time to write one by one code. So let me understand here. From Pyspark, I import structure type, structure field, string data type, which is integer data type, double type, and date type. And I have also imported here delta dot tables from import here from this library. I am imported here delta table to create as a delta from Pyspark. We created in here table. Okay, so we imported here delta table, and structure of table here stack type we use here to define the column name, and the column name is defined by stacked field, and a customer ID which is string, and so on. You can see here. And we need to write here from library delta table dot create. If not exist, then we use here Pyspark, then table name which is dim customer, then add column which is this one. We defined here schema, okay, and then need to execute. So let me create here. You can see here there is no any customer table yet created. So let me execute to create. Now this cell is successfully executed. Now if you refresh this here, it should be created here dimension customer dim customer table. So let me also create quickly dim product table and fact table. So now we are going to create here dim product table. Escape, press M to heading. And let me paste here our already created script same as above. Okay. So let me execute. Now we are going to create here fact sales table. So let me write here sales table. So escape, press M, and now add new cell, and let me copy already created here script. In dimension table, we take only product ID. In dimension product table, we take only product IDs, category, subcategory, and product name. And in fact table, we take all transaction detail. For example, row ID, order date, customer ID, product ID, order date, ship date. We take here 2 times ship mode, sales quantity, and so on. Okay, so let me execute this one as well. So executed. So let me refresh this. And we have all 2 dimension table, dim customer, dim product, and one fact table, fact sales. Okay. So now let me load data into dim customer table first. So I need to write here adding loading data into dim customer. I will also put this notebook in description box as a downloaded link. You can download and do practice. So we need to create here a script. So I already created here a script. Basically, we take here from our data frame DF and selecting only those columns which we available for customer, dimmed customer, customer ID, customer name, and we selected only those columns to load into customer table, and we also remove duplicate value. Okay, and creating one variable df selected dim customer. So let me execute. Okay, and now we using here merge statement to load data. So let me copy and paste here. Basically, we also here imported delta dot table and imported all library from this, all function from this library, and we also take here dim customer table path. So this one is our path, and let me replace here path, new path. Okay, and we defined here delta table for our dim customer table path. So we have a dim delta customer as a variable to create here dim. This is our target table. This is our dim customer is our target table, and df selected dim customer our source. Okay, and we defined here we comparing here customer ID from target to source, and if this match, then we want to update customer name, segment, postal code, city, state, and so on. And if not match, then we need to insert into dim customer table. So we take customer ID to insert customer name, segment. Here we do not want to update because it's comparing. If already have a data, then we only want to update data, and if not, then we totally insert into customer table, and after that if not match, then we want to insert. Okay, so let me execute. We need to also write here dot execute if using Pyspark method. Okay, in previously we in silver layer and bronze layer we only write a script using SQL. Now we take here a script as a Pyspark method. Okay, so let me execute. Still executing. It's take time 24 seconds. You can see here. So after 33 seconds, this cell is executed, and let me see how many in this method. You cannot see here how many row affected, how many row inserted and updated. So we need to also write here code because every table has a history. So we take here dim delta customer as a history, and let me execute this code. Total row of cells executed here 849, total row of table and inserted 849. Okay, so that makes sense. There is no data, so totally data incoming data inserted. Okay, now let me quickly also insert for dim product. So also loading data into dim product. Escape, press M for heading, and let me quickly put here our script for dim product. We already created here escape to save time, and also let me take here merge statement same as dim customer. So we take only here our target as a delta product and source our selected this column. Okay, and apply same logic. If match, then update. If not match, then insert. Okay, so let me execute. So here after 6 seconds, this is executed, and let me also validate. Here 1185 row is affected, means this amount is row inserted. That makes sense because there is no already records in dim product. So all row is inserted. Okay. Now let me insert fact table. So let me also heading this loading into fact cells. Let me copy code quickly and paste here. And let me also take here merge statement, same logic as we do for dim customer and dim protect. Okay, so let me execute. You can see here we take path for fact cells. After that, we also created here delta cells, and we already created here selected cells from our data frame, and also remove here duplicate value and compare with order ID. If this is match, then I want to update all column from the fact table. If not match, I want to insert all row from the silver layer to gold layer. Okay, so let me see how many row which affected. Okay, let me execute now. So all row from the silver layer coming record is inserted into gold layer for our fact table, which is going to be transaction table. Okay, so from here we created here gold layer in which we create here three table, two each dimension and one is fact. Now we are going to represent this data in Power BI. Okay, now let us move one step further and see how exactly we can perform data modeling using our these three table: team customer, dim product, and fact sales. So let me go to here workspace and let me open this our lake house, and let me go to here SQL analytics endpoint. So click here to create our semantic model. Go to here reporting and select here new semantic model and name this sales semantic model. Semantic model, and let me choose here table our dim customer, dim product, and our fact table. Okay, so let me confirm. Wait to open this semantic model view. So here is semantic model preview is open, and then now let me drag here, and you can see here in editing mode. It should be in editing mode to join this fact and dimension table. So I want to join here with product ID to product ID from dim customer to fact table. So let me drag here and join. Here fact table and here is dimension table. So from fact to dimension here many to one relationship. So let me save, and for same way let me use here customer ID and let me join with customer ID, and this is also going to be many to one relationship. Okay, now let me create here some Power BI report. So go to here and let's create new Power BI report. Okay, so let me quickly create here. This is our fact table, and this is our product, and this is our customer. So let me use here product name, not product name. Let me use here product category, and this is I want to use here pie chart, and let me use here profit margin. This should be in value. Okay. Let me now use here subcategory. So I want to create here just for our, this is not Power BI class. So for our learning purpose, I'm just creating some view. So let me use here sales. This is our sales. Okay. And let me one more create here. Let me use here scatter chart. So I want to do here relationship between sales and profit and using, let me use here product ID in legend. Okay. And if you want to create here, let me create here also card. This card should be above, but let me see here. This is our sales amount. So we can represent here our semantic model here, and we can create here our report. Okay. So let me save this sales report and save this. And this report is going to be saved here. Sales report, and we also create here semantic model, sales semantic model. Okay, so let us now orchestrate everything together. So far we have been moving our sales data step by step from door to landing, then landing to bronze, bronze to silver, and silver to gold, and then finally we create Power BI report. But until now, each step was running individually by running any notebook. Okay, so it's time to switch everything into automated pipeline. So first thing, we already automated row to landing ingestion. Now let's orchestrate the rest of all notebook. As on new data land in row, we will schedule this pipeline at a given time. Okay. To achieve this, we need to automate this. We need to make sure all notebook are parameterized. For example, our landing to bronze. Here is a landing to bronze. This should also be parameterized. And here is a parameter is today date. So let me cut and insert one cell and go to here three dot and let me toggle this parameter cell to parameterize. Okay, so you can see here this is now it's a take hard coded value here, but it take dynamically from the pipeline. Okay, so let me do for the rest of notebook as well. Landing to bronze we already did. Then silver transformation. Let me also go to here three dot and parameterize this toggle parameter, and again go to here. Now click on silver to gold. Also do here toggle parameter cell. Okay. So do for parameter landing to bronze, silver transformation. This is also parameter. Now let's create pipeline. To create pipeline, click here new item and click here data pipeline and name it end to end orchestrate. Okay, so let me click here create button. So we already created for row to landing pipeline. So let me invoke pipeline activity. So go to here and invoke pipeline. So let me click here and this is row to landing. Okay, and go to here setting and let me select here our fabric workspace. Okay, sign in. Okay, connect. So let me use here PL row to landing pipeline our. Okay, so in this we do not require any parameter because we already defined parameter in end to PL row to landing pipeline. You can see here, go to here and you can see here parameter we already define, go to setting and base parameter here. Okay, we already defined processing date. So let me also copy this formula to define for other notebook. So now let me go to end orchestrate pipeline, and now let me use here notebook in canvas and connect this, and this is landing to bronze, and go to here setting and let me use here landing to bronze table, and this we have one parameter which is today date, and this is a string, and let me paste here value for today date, and this is going to be landing to bronze, and this is our parameter name. So go to here again and paste here parameter. Okay. So we take here notebook landing to bronze and parameterize today date. And we do not require here, only require here today date. Okay. Now let me again one more notebook for bronze to silver, which is silver transformation. Silver transformation, and go to here setting, and let me use here silver transformation demo. And in this we have also silver. Go to silver transformation. This is our parameter. So let me use here this parameter, and this is also going to be a string. And now go to here and let me copy this formula, which in which we use UTC now in formatted with YYYY MM and DD format. So I'm using same today date and paste here value. Okay. And again one more transformation, which is gold transformation, silver to gold. Okay. Go to setting and let me use here silver to gold base parameter. We have only one today date. Let me use here this formula here, and this is a string, and in go to here, and this is silver to gold, and we have also today date. Copy exactly same. Here is case sensitive parameter, so we need to copy exactly same. So go to here again and put here parameter. Okay. So we automate all notebook in one pipeline. Okay. So now let me go to here fabric and open here, and let me delete this one and upload another file. So get data, upload file. So let me use here July data. Okay. Upload. Okay. So here file is loaded, and now go to here end-to-end orchestrate pipeline and let me execute. Go to here and first save this pipeline and let me run. So let's wait to execute this pipeline. So you can click here to refresh the pipeline, and you can see status of pipeline progress. So click here to refresh and see status here. Row to landing is succeeded. Landing to bronze also succeeded. Silver transformation pipe notebook is also succeeded. Waiting for gold transformation from silver to gold transformation, which is in progress. You can see here duration of execution time. So row to landing take 2 minutes 47 seconds. Landing to bronze take 1 minute 9 seconds. Silver transformation take 1 minute 10 seconds. Let me refresh this. And you can see here silver to gold transformation is also succeeded. 1 minute 25 seconds it's take. You can see here we already see row to landing. Let me see here landing to bronze. And if you click here, and you can see a snapshot of a notebook. So let me check here. Let me wait to load. Here, parameter you can see it's take 7th of September 2025. Today is 27th September. Okay. So it directly take, and all here transformation and all step is here loaded. Okay. So now go to here fabric workspace, and if you go to here report, and it's automatically refresh, and if you check here it's automatically take the data from the model. Okay. So in this video we have seen how to architect end-to-end pipeline and entire data pipeline from row to gold layer. So that's all about in this video. If you find this video helpful, please subscribe this channel, like this video, and also share with friends. And if you have any question, feel free to ask using comment box. Thank you for watching. Have a nice day.